Welcome viewers. In this video, I am going to share with you solution of question number 2 from exercise 7.3. If you feel this video is helpful for you, then like, share and subscribe the channel. Let's start solving question number 2. AD is an altitude of an isosceles triangle ABC in which AB equals to AC. Show that number 1, AD bisects BC, and number 2, AD bisect angle A. Diagram is not given, so we have to draw the diagram first. ABC is an isosceles triangle in which AB equals to AC given and AD is the altitude, that is this angle and this angle both 90 degree. We are going to show AD bisects BC. AD bisect BC means BD equals to DC, that is this length equals to this length, and AD bisect angle A means this angle equals to this angle. Proof. If we observe the question carefully and the diagram which I have already drawn, you can see that if we can prove triangle ABD and triangle ACD are congruent, then by CPCT we can say this side, that is BD equals to DC, that is AD bisect BC, and angle BAD equals to angle CAD, that is AD bisect angle A. So let's prove the triangle ABD and triangle ACD are congruent. In triangles ABD and triangle ACD, we have angle ADB equal to angle ADC, as because AD perpendicular on BC, therefore angle ADB equal to angle ADC equal to 90 degree. Since AD is the altitude, therefore this angle and this angle must be 90 degree, and it is also given that AB equals to AC, given. and AD equals to AD common. Side AD is common to the both triangle ABD and ACD. Therefore, triangle ABD congruent to triangle ACD by RHS congruent rule. So, we already proved triangle ABD congruent to triangle ACD. Since triangle ABD congruent to triangle ACD, therefore BD equals to DC by CPCT, that is AD bisects BC. Again, since triangle ABD congruent to triangle ACD, therefore triangle ABD congruent to triangle ACD, therefore we can say angle BAD, therefore angle BAD equals to angle CAD. These two angles, that is angle BAD equals to angle CAD, that means AD bisects angle A. So this is proof number 2. No more today. I wish you all the best.